All right, so day 4, number 9, we are going to square both sides to cancel out the first square root. And then we get x minus 5 plus x equals 25. Then we're going to subtract x from both sides to isolate that radical. So we get the square root of x minus 5 equals 25 minus x. Now when we square both sides, we have to be careful and square this binomial. When we square the binomial, we actually have to FOIL 25 minus x times itself. And when we do this, we get 25 times 25, I believe, is 625. We get a 25x, and a 25x is a negative 50x, and then a positive x squared, because negative x times negative x is x squared. So you get that negative 50x in the middle. You can't just square both terms. And on this side, we still have x minus 5. Now, when I get 0 on one side and rewrite it so it looks like a normal quadratic, I have a positive x squared. I have a minus 51x. And let's see, when I add 5 here, I get a plus 630. Okay. Probably the fastest way to solve this is to factor. We're looking for two things that multiply to 51, multiply to 630 and add to 51. They've both got to be minus signs, since it's a negative 51 and a positive 630. And I'm thinking probably 21 and 30, or 31 and 20 look likely. So I'm going to double check that on my calculator real quick. Let's see, 21 times 30 is 630, so it is 21 and 30. So that means x equals 21 or x equals 30. Now, since we squared both sides, we should go back up and check for extraneous solutions by plugging it back into the original problem. I'm going to go ahead and leave that for you guys to do. You could also, if you didn't want to have to plug it back in, you could check this graphically. So you could plug in the original problem, so the square root of the square root of x minus 5, let's see, plus x, make sure I close that parenthesis, equals 5. And then I'm looking, I know x is going to be 21 and 30, so I'm going to have to adjust my window from, let's see, I better make it go out to at least 35. I'm going to count by 5s. I want to know when it equals 5, so that window is good. And when I graph it, it's either going to cross the graph once or it's going to cross the graph twice. Now here it looks like it only intersects once. So if I hit second trace, intersect, enter, 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 I see that the intersection is at 21, and there is in fact no intersection at 30. That means 30 is an extraneous solution, and x equals 21 is our only answer. Let's see, the next problem that I have, I can probably fit one more in this video, is day number 4, and it's problem number 15. It's the problem where 5 to the x equals 4 to the x plus 1. Frankly, the easiest way to solve this is with your calculator again. So I'd plug 5, let's clear that out, 5 to the x and 4 to the x plus 1 into my calculator. And then I'm going to hit zoom 6 just to take myself back to a standard window. Now, when you graph two exponentials, it doesn't always look to the naked eye like they're going to intersect. However, I hit second trace and intersect, and then enter, enter, enter. It's taken a while to think about it. My calculator says that it intersects at 6 and 21,000, almost 22,000. So if I fix my window and make my y values go all the way up to, let's say, 23,000, and I'm going to narrow my x's to go from 0, well, let's go actually from 3 to 7. It'll be a better window. So I'm kind of zooming in around that place. There's the first, that's 5 to the x. Here's 4 to the x plus 1. And you can see that they do in fact intersect right up at the top here. So second calc intersect one more time, enter, enter, enter to get that answer back. I get x is approximately, anytime now, 6.21, let's go at 4 decimal places, so 26. And then to show my work on a problem like this, I would draw a picture of the graph. I would sketch one curve and then the other curve, and I would label that intersection point just to show how you got the answer.